Pluto is smaller than Earth's moon. It sits nearly 6 billion kilometers from the sun, and there may be a liquid ocean hidden beneath its surface right now. For decades, nobody thought that was possible. Pluto was classified as small, frozen, and geologically dead, a leftover from the early solar system with nothing interesting left to offer. In 2006, it lost its planetary status, and most people stopped thinking about it entirely. That assumption was wrong in almost every way it is possible for an assumption to be wrong. In July 2015, NASA's New Horizons spacecraft completed a 9.5-year journey across the solar system and flew past Pluto for the first and only time. What its instruments recorded in those few hours overturned everything scientists thought they knew about small, cold, distant worlds. But here is the thing nobody talks about. The deeper scientists looked at what New Horizons had found, the more one question kept surfacing. A question that still does not have a definitive answer. Not just whether Pluto is active, but whether something is happening inside it right now that nobody predicted was possible this far from the sun. That question runs through the entire story. New Horizons had no ability to slow down or enter orbit. One pass, one opportunity. At roughly 50,000 kilometers per hour, it swept past Pluto in a single window of a few hours. Instruments running at full capacity, recording everything it could before the window closed. The first images began arriving weeks later. Scientists expected ancient terrain, a world covered in the accumulated scars of 4 billion years of asteroid bombardment, craters on top of craters, a frozen record of the early solar system left completely unchanged since the beginning. Instead, they found smooth plains, young surfaces, terrain that looked freshly formed, mountain ranges that appeared sharp and new rather than worn down by time. A world that every existing model said should be geologically dead was showing signs of something far more difficult to explain. Something has been happening on Pluto recently. The question was what? And more pressingly, what was powering it? The feature that stopped scientists cold sits in Pluto's northern hemisphere. A vast, bright region shaped loosely like a heart, now designated Tombaugh Regio. Its western lobe, a basin over 1,000 kilometers across filled with frozen nitrogen called Sputnik Planitia, should have been one of the most cratered surfaces in the solar system. It had almost no craters at all. In planetary science, craters are clocks. They accumulate over time, and their density tells you how long a surface has been sitting unchanged. Sputnik Planitia's near absence of craters suggests portions of it are geologically young, likely younger than about 10 million years, with some models suggesting active renewal on even shorter timescales. On solar system timescales, that is not old. It is astonishingly recent. But the crater count was not even the most striking thing about it. Look at the surface of Sputnik Planitia in the New Horizons images, and you see it divided into irregular cell-like shapes, each one roughly 10 to 40 kilometers across. They look almost biological, like the surface of a living thing viewed under a microscope. What they actually represent is convection. Warmer nitrogen ice rises slowly from below, spreading across the surface, cooling and sinking again before being reheated and rising once more. Picture a lava lamp, warm blobs rising, cooling at the surface, sinking back down, endlessly. Now scale that up to a basin the width of a small continent, made of frozen nitrogen, operating on timescales longer than human civilization has existed. That is what Sputnik Planitia is doing right now, and the question it raises has no clean answer yet. Where's the heat coming from? Pluto sits 5.9 billion kilometers from the sun. At that distance, sunlight arrives roughly 1,500 times fainter than it does at Earth. Surface temperatures sit near minus 230 degrees Celsius, cold enough for nitrogen, which is a gas in the air you're breathing right now, to freeze solid on the ground. A world that cold should have exhausted any internal heat source billions of years ago. Several explanations are being investigated. Residual heat from Pluto's formation, the thermal memory of a violent birth, still bleeding slowly into the rock 4.5 billion years later. The decay of radioactive elements deep in its core. A quiet internal fire that needs no star. It simply runs on its own clock across geological time, or something else entirely. Something that, if confirmed, would change how scientists think about the entire outer solar system. Hold that thought, because it matters more than it first appears. Step away from Sputnik Planitia, and the strangeness continues in every direction. Near its boundary, mountain ranges rise more than 3 kilometers above the surrounding plains. Not mountains of rock, but water ice, which at Pluto's temperatures behaves like stone, rigid enough to hold enormous topographic relief across geological timescales. The mountains look sharp and young. Whatever shaped this terrain was not a relic of the past and may still be at work today. But the mountains are not the only sign of activity here. Nitrogen glaciers flow from higher terrain into lower basins, slowly reshaping the landscape the way water glaciers do on Earth, except that the ice is made of nitrogen, and the process plays out over timescales humans cannot observe directly. But the marks it leaves behind are unmistakable. And then there are the dunes, in a place where the atmospheric pressure is roughly 100,000 times lower than at Earth's surface, closer to a laboratory vacuum than to anything we would recognize as air. Pluto has fields of dunes made from methane ice particles. Wind alone should not be strong enough to move anything. What appears to be happening is that sunlight warms surface nitrogen ice just enough to convert it directly from a solid into a gas, and that escaping gas kicks methane particles upward where even Pluto's faint winds can carry them across the landscape. Nobody predicted this. In a near vacuum at the edge of the solar system, Pluto is actively sculpting its own terrain, which raises the next question. If the surface is still this active, what is happening deeper down? 2 large structures in Pluto's southern hemisphere have attracted particular attention. Right Mons and Picard Mons are broad, elevated features with collapsed central depressions, a shape familiar from volcanic systems on Earth and other planetary bodies. The surrounding terrain shows few impact craters, suggesting the surface there was renewed not long ago in geological terms. The hypothesis being investigated is cryovolcanism, eruptions not of molten rock, but of material from the interior, likely a mixture of water ice, ammonia, and other compounds that reaches the surface and spreads before freezing. Cryovolcanism on Pluto has not been confirmed. The structures are consistent with it, but consistency is not proof, and the science remains open. What is not open is that these features exist, that they are large, and that no alternative explanation fully accounts for them. And if cryovolcanism is real, it means material from somewhere deep inside Pluto has been reaching the surface. The inside and the outside may not be as sealed off from each other as anyone assumed. Which brings everything back to the question, what is down there? The evidence starts with position. Sputnik Planitia does not sit where you might expect a random impact basin to sit. It lies almost exactly on the line connecting Pluto and Charon, the axis their gravity pulls toward. That is not a coincidence. That is physics. Something beneath the basin is heavy. Heavy enough that over millions of years, Pluto slowly rotated until that mass settled into gravitational alignment, like a weighted ball finding the bottom of a bowl. The basin moved to where the planet's gravity wanted it to be. What could be heavy enough to do that? One explanation: water. Liquid water, held from freezing by ammonia, acting as a natural antifreeze, pooled into a buried ocean beneath kilometers of insulating ice, and never seen from the surface. No one has seen it. No instrument has touched it. It remains a hypothesis, but it is a serious one, and it keeps fitting the data. Europa and Enceladus have strong evidence supporting subsurface oceans. The possibility that Pluto, smaller, colder, and further from any tidal heating source, might belong in the same conversation is something planetary scientists are now genuinely considering. A hidden ocean, in the dark, nearly 6 billion kilometers from the sun, sitting undisturbed beneath kilometers of ice, possibly for billions of years. Pluto's atmosphere is almost nothing by Earth standards, primarily nitrogen with traces of methane and carbon monoxide at pressures 100,000 times lower than sea level. It should be inert, frozen, dead. Instead, sunlight is tearing it apart and rebuilding it into something else entirely. New Horizons photographed it in silhouette and found layered blue haze extending hundreds of kilometers above the surface. Sunlight breaks apart atmospheric molecules and reassembles them into complex organic compounds called tholins, which drift slowly downward and give Pluto its reddish-brown surface coloring. That atmosphere swells and partly freezes back to the ground, depending on where Pluto sits in its 248-year orbit around the Sun. A world this small, this cold, this far. And it has weather. It has chemistry. It has a sky, which raises a question that goes far beyond Pluto. If this much is happening here, what might be happening in the thousands of other frozen worlds we have never looked at closely? Pluto's largest moon, Charon, compounds everything. At roughly half Pluto's diameter, it is so large relative to its host that the two bodies orbit a shared center of gravity that sits outside Pluto itself. Less a planet and its moon than two worlds in a locked stare across a gap of roughly 19,500 kilometers, each permanently facing the same side toward the other. Charon has its own story written on its surface. A vast canyon network reveals evidence of ancient internal expansion, and its north pole is stained dark red by tholins that didn't originate on Charon at all. They came from Pluto. Methane escaping from Pluto's atmosphere drifts across the gap, freezes onto Charon's polar region during its long winter, and is slowly transformed by radiation over time. Pluto is painting another world, not through impact, not through any direct physical connection, simply by existing and slowly breathing its atmosphere into the space between them. Pluto's diameter is roughly 2,377 kilometers, smaller than Earth's moon. By the logic that governed planetary science before 2015, a world this size at this distance should be a frozen relic, geologically finished, chemically inert, a piece of the early solar system preserved in cold storage. Instead, convecting nitrogen plains, water ice mountains, nitrogen glaciers, methane dune fields, possible cryovolcanoes, a layered atmosphere, a moon being chemically altered from across a void, and beneath all of it, possibly, a liquid ocean that has been sitting in complete darkness for billions of years, insulated from the cold above by kilometers of ice, heated from below by processes that are still being worked out. The assumption was wrong, and that may be the most significant realization of all. Pluto did not break the rules. Pluto showed us the rules were never complete. The Kuiper Belt contains thousands of icy worlds, and a handful approaching Pluto's own size. The largest among them are Eris, Makemake, and Haumea, each recognized by the IAU as official dwarf planets. Eris, Makemake, Haumea. Hundreds more that have never been visited, never been imaged at close range, never been measured for internal heat or surface activity. They were filed under the same assumption applied to Pluto: too small, too cold, too far. That assumption was wrong once. It may be wrong again across thousands of worlds we have barely begun to see. No return mission to Pluto has been approved. The far side was never fully imaged. The ocean hypothesis cannot be tested from flyby data alone. The heat source has not been confirmed. The full picture of what Pluto is doing inside remains incomplete. One spacecraft, 9.5 years of travel, a few hours of data collection. That was enough to show that the edge of the solar system is not a graveyard of frozen leftovers. It may be full of hidden oceans, quiet geology, and worlds that have been doing extraordinary things in complete darkness for billions of years, with nothing and no one to observe them. We looked at Pluto once. What we found should make us question every world we stop looking at.